Significant figures includes all of the digits that are known plus a last digit that is estimated. I want us to write something in here that's very important. Significant figures are only used when we are talking about measurements. And if I could spell measurements, that would be great. Measurements, things that you do in a lab setting. Things when you're using a piece of equipment like beakers, graduated cylinders, scales, rulers, anything that can be measured, we're going to have to use significant figures. It levels the playing field for all scientists so that we all know which digits are important and which digits are not. We are going to learn how to properly calculate things in science, finally. No more guessing about how many digits to round to. These rules are important. They will be in every calculation until the end of the school year. So this is crucial. So let's get to it. Here's rule number 1. Pause as needed to go through these rules. Pause if you need a second to just absorb and reflect. Rule number 1, all non-zero digits are significant. These are your counting numbers. So if you want to jot down a little extra note, these are all your counting numbers, 1 through 9. Rule number 1 is the easiest rule. Rule number 2, the rest of the rules are going to involve the zeros that we see in measurements. So rule number 2 says the zeros between non-zero digits are significant. We call them zero sandwiches, and here's why. 102. Do you see the zero sandwich? It's right there. It's sandwiched between two numbers. So if we're counting which digits are significant, we have 3 of them. All of them are significant. 3. 7,002. Do you see any zero sandwiches? There are 2 of them. So if we're counting, we have 4 significant digits that we're going to use. Rule number 3. Leading zeros at the beginning of a measurement are never significant. I would star this one. It's the second to hardest rule. Here's an example. I have 3 counting numbers according to rule number 1. I have 2 leading zeros. Are they significant? Does it matter where the decimal is? No. So in this measurement, there are 3 significant figures. I see 3 counting numbers. Again, 2 leading zeros. Are they significant? Nope. Only 3 significant figures in this number. Rule number 4, I want you to circle it, star it, smiley face. It is the hardest rule. It says trailing zeros are significant only if the number contains, and I would box this in right here, decimal point. 210.0. Is this 0.0 important? I don't know. Let's look at the rule. Here are my 2 counting numbers. These are called trailing zeros because they trail counting numbers. Is there a decimal? Yes, there is. So all 4 are significant. 0.860. I've got 2 rules here. Rule 3 and Rule 4. Let's point them out. I see a leading zero. That's Rule 3. I see a trailing zero. That's Rule 4. Which ones count? Those 3 right there. So there are 3 significant digits. Pause if you need to take a second to get that. 210. I see a trailing zero. I don't see any decimal point. So it is not significant. There are only 2 in this number. And the last rule, which kind of follows along with all the other rules, all digits are significant in scientific notation. So what we're going to look at is what we call the coefficient, which is this right here. We do not look at the power of 10 to determine significance of our measurement number. How many are there? According to rule number 1, there are only 2 significant digits here. How about this guy? Okay, I have a rule 2. Remember the 0 sandwiches? There are 3 significant digits here because I'm not looking at the power of 10. Time to practice. I'm going to write the rule number to the side so you can see which rule I'm referencing, and then I'm going to tell you how many significant digits are in each of these numbers. And I'm going to change this word numbers to measurements because that's what they are. They're measurements. And because they're measurements, they should have units on them, like milliliters, grams, liters, but they don't. So just bear with me right now. 1.2. This is rule number 1. There are 2 significant digits, both counting numbers. Letter B. This is going to be rule number 3. There is a trailing 0 and there is a decimal. So I see 2 significant digits. 1, 2. C. This is rule number 2. I see 2 0 sandwiches, which means they are all significant. There are 4 significant digits there. Letter D. I see a rule number 4. And excuse me, I'm going to go back and change this. Letter B should be rule 4. I see 2 trailing zeros. There is no decimal place, so there are only 2 significant digits here. E, I see another rule 4. I see a trailing 0. Is there a decimal place? Yes. So 1, 2, 3, 4, 5. All of them are significant. And the last one, I see rule number 5 along with rule number 2. I see a 0 sandwich, and we're not going to use these for scientific notation. So there are 3 here. One last thing to note is that exact numbers have unlimited significant figures. So what am I talking about? When you are counting things and you do not need something to measure it with, like a beaker or a scale or a graduated cylinder or a triple beam balance, you don't have to use significant figures. So there will be times when we don't follow these rules because we didn't have to measure something.